Hopefully it got most of it. All right. Oh, you want still writing? Okay. Okay, so let's say for our next example, we want to compute the exact value of sine of pi over 12. And just make a quick note that sine of pi over 12 is actually equal to sine of pi over 3 minus pi over 4. Okay. So since we already know our formula, sine of a minus b equals sine of a. Oh, clean that up a little bit. Cosine of b minus sine of b times cosine of a. We can solve for our sine of pi over 3 minus pi over 4. We'll just make this our a, and we'll make this one our b. Okay. So this is going to equal sine of a, so sine of pi over 3, times cosine of b, so cosine of pi over 4, minus sine of b, which is sine of pi over 4, times cosine of a, which is cosine of pi over 3. Okay. So our sine of pi over 3, that's square root of 3 over 2. Our cosine of pi over 4, that's square root of 2 over 2. Sine of pi over 4 is square root of 2 over 2. And cosine of pi over 3 is 1/2. Okay. So now we just multiply everything together and simplify it the best we can. Okay. So square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Minus square root of 2 times 1 is square root of 2 over 2 times 2, which is 4. Okay, so the best we can do here is square root of 6 minus square root of 2 divided by 4. And that would be your exact answer. Yes?
How did you get pi over 12 equals pi over 3 minus pi over 4?
Oh, for that one, so if you have, say, sine of pi over 3 minus, well, actually don't even need the sign right here. Let's say if you just have the pi over 3 minus pi over 4. If you multiply this one by 3 over 3, and this one by 4 over 4, you get 4 pi over 12 minus 3 pi over 12, which is just 1 pi over 12. Does that make sense?
Yeah.
Okay. You're welcome. Okay. Any other questions on this one? Okay. I'm still writing. Okay. say, for example, if we're given that sine of A is equal to negative 7 over 25, and that's in quadrant 4, and we're also given that cosine of B is equal to negative 3 over 5, and that's in quadrant 3. Okay, so from that we want to find our sine of A plus B. Okay, so to do that we need our sine of A, sine of B, cosine of A, and cosine of B. Okay, so once again, first thing you want to do, draw your triangles. And in this case, you're going to draw one in quadrant 4, and you're going to draw the other in quadrant 3. Okay, so remember in quadrant 4, that's your sine of A. So we'll put our A here. And in quadrant 3, put our little right angle sign there. This is our cosine of B. Okay. So we know sine of A, remember that's opposite over the hypotenuse, which is negative 7 over 25. Okay, so it means your opposite is 7. So from A, your opposite is 7. And your hypotenuse is 25. For cosine of B, cosine is adjacent over the hypotenuse, which is negative 3 over 5. So this is your angle B. Your adjacent is 3, and your hypotenuse is 5. And again, once you have the two sides, you just use the Pythagorean theorem to solve for the third side. And we can actually go back to the example we did before, and we know that this is 24, and this one is actually 4. So use Pythagorean theorem. Solve for the missing sides. Okay, so once again, we have our given that they gave us right at the very beginning. So our given is that sine of A is equal to negative 7 over 25. And our cosine of B is equal to negative 3 over 5. Okay. Now the ones that we actually found with our triangles, we have sine of A, so we now have to find sine of B. So our sine of B, which is opposite over hypotenuse, is 4 over 3. But remember, this is your X and my Y here. X and Y. Sine is your Y value. And in quadrant 3, your Y is negative. So this is actually going to be negative. So actually, I'll make that a little bit longer so I can write that note there. Sine theta is negative in quadrant 3. Yes?
Shouldn't sine of B be 4 over 5?
Oh, thank you. I don't know why I did that. Yep, 405. Okay, now cosine of B we already have, so now we just have to find cosine of A. So cosine of A is adjacent over hypotenuse. So that's 24 over 25. And in quadrant 4, that's your, remember, x equals cosine of theta is positive in quadrant 4. Okay, so that stays positive. Okay, so now that we have everything, we just plug it into our formula. So sine of A plus B equals sine of A times cosine of B plus sine of B times cosine of A. Okay. So our sine of A is negative 7 over 25. Our cosine of B is negative 3 over 5. Plus our sine of B is negative 4 over 5. And our cosine of A is 24 over 25. Okay. So once again, we just start multiplying and simplifying all our terms together. So you have positive 21 over 125 minus 96 over 125, which simplifies to negative 3 over 5. Oops. Okay. So any questions on that one? Actually, it should have been negative 75 over 125, but simplifies to 3 over 5. All right. Hope anyone's still writing. Leave that up there for a few more seconds. All right. So let's say for our next example, we want to simplify cosine of pi over 2 minus x. And actually, problems like this are a lot easier because you don't have to worry about drawing any triangles. Okay, so remember our formula, cosine of A minus B equals cosine of A times cosine of B plus sine of A times sine of B. Okay, so if we have our cosine of pi over 2 minus x, where we'll let our pi over 2 equals A, and our x is B. If we plug those in, cosine of pi over 2 times cosine of x plus sine of pi over 2, we'll clean that up, times sine of x. Okay, so our cosine of pi over 2 is 0 times cosine of x plus our sine of pi over 2 is 1. Draw a little arrow there. Times sine of x. Okay, so this just disappeared. 0 times anything is just going to be 0. So you end up with just sine of x. All right, so any questions on that one? All right. And now start on a new page. Make sure I have enough room. Oop, everyone's still writing. Oh, okay. All right, so let's say for our next example, we want to compute the exact value of sine of 285 degrees, which means actually showing the steps. Okay. So just like we did with our pi over 12, we can separate this. So 285 degrees is actually equal to 240 degrees plus 45 degrees. Okay, now 240 degrees, we can find our reference angle. Okay, so if we had our 90 degrees, 180 degrees, 270, and a complete circle, it's 360 degrees. So 240 is somewhere over here in quadrant 3. Okay, so our reference angle in quadrant 3 is equal to theta minus, well, instead of pi, 180 degrees. Which is 240 minus 180. Which is 60. So our reference angle in quadrant 3 is 60 degrees. Okay, so right now we're just going to block that off because we're going to see exactly why we need that. All right, so if you have sine of 285 of 285 degrees, we already know that that's sine of 240 degrees plus 45 degrees. Okay, so just using that as our A and B, that's equal to sine of 240 degrees times cosine 45 degrees plus sine of 45 degrees times cosine of 240. Okay. Now we know that in quadrant 3, sine of 60 degrees, or you can put y equals sine of 60 degrees, is negative. Okay, so we know that sine of 60 degrees is equal to negative square root of 3 over 2 in quadrant 3. Same thing with cosine. Well, I actually should have put the, just to clarify it, I don't want anyone trying to figure out where that 60 came from. So sine of 240 equals sine of 60, which is negative square root of 3 over 2. Is negative in quadrant 3. Okay, and we do the same thing for cosine of 240. And quadrant 3, because remember, x is our cosine. X equals cosine 240 equals cosine of 60. Remember, that's our reference angle. So our cosine of 60 degrees is also negative. Negative in quadrant 3. Okay. So we have our cosine of 45 and sine of 45. We can figure that one out. But now we have our reference angle here. Okay. So sine of 240 degrees, we know that's negative square root of 3 over 2. Times cosine of 45 degrees, square root of 2 over 2. Plus our sine of 45 degrees, which is square root of 2 over 2. And our cosine of 240, which is negative 1/2. Okay. So once again, we just combine our terms and simplify. Square root of 3 times 2, that's going to be negative square root of 6 over 4. 2 times 1 will be minus square root of 2 over 4. So this one will be negative square root of 6 minus square root of 2 over 4 as our exact value. Oh, move this up a little bit. All right. So any questions on that one? All right. Leave that up for a few seconds. All right. Okay, so for example, can't forget about tangent. Say we want to simplify tangent of theta plus 3 pi. Okay, so we know that our tangent of theta, well, not tangent of theta, tangent of a plus b equals tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b. Okay. So for our tangent of theta plus 3 pi, we'll let our theta be our a, and our 3 pi will be our b. Okay, so that's going to equal, that's a little bit crooked, tangent of a, so that's tangent of theta, plus tangent of b, which is tangent 3 pi divided by 1 minus tangent of theta times tangent of 3 pi.